factor these polynomials, but they give us one of the zeros. So it turns out when we know one of the zeros or roots, then you can use synthetic division to reduce the polynomial so that we can factor it further. So for example, in number 17, if you were asked to factor that, looking at it, what method, what technique for factoring do you think that we would use for number 17? Grouping, right? Because it's a cubic function, it's degree 3, and it has 4 terms. But look really closely. If we started the grouping process, would we get the same linear term when we take out the GCF of the first 2 terms? What would we be left with? X plus 5. When we take out the GCF right here, what would we be left with? X plus 12. Okay, for grouping, those have to be the same thing. They're not. So it turns out that this is not factoring by grouping, but they're really nice to us, and they tell us that one of our zeros is 2. So what we're going to do is we are going to use synthetic division with 2 on the shelf to reduce this from a cubic polynomial. Once we plug in this 0, then we're going to have a quadratic that hopefully we should be able to factor. Now, I get a remainder of 0. I better get a remainder of 0 because they tell us that 2 is a 0. Remember that remainder theorem. If it is a 0, or if you get 0 as the remainder, it means that number is a 0 or a solution or a root. Okay, so we started with x cubed, so this is 1x squared plus 7x plus 12. Can we factor that? I sure hope so. Okay, that is what? X plus 3 times x plus 4. Okay, and we've got to include that 0 that they already gave us. They told us that 2 was a 0, so x minus 2 is its linear factor. Okay, so this is the factored form of x cubed plus 5x squared plus minus 2x minus 24. Now, instead of checking it by multiplying it back out, because that's going to take a little bit of time, one way that you can check it is to plug in the polynomial in y1 and plug in your factored form in y2, and then we need to either look at the graph and make sure that they overlap, or I prefer, and you have to be careful with your parentheses, I prefer to look at the table and make sure that all my y values agree. Okay, if I go to the table and every y value that I see right there is the same for y1 and y2, that means those are the same polynomial. One's just in standard form, one's in factored form. Okay, so that's a really easy way to check yourself on these problems. Okay, let's do number 18 as well. Okay, number 18 as well. So again, looks like grouping, but if we started the whole grouping process, we're not going to get the right conditions. So we need to, they told us that 3 is one of our zeros, so we do synthetic division with 3. We get 0 as the remainder, which is what we're expecting. It was x cubed, so we reduce it down to x squared minus 4x plus 3, which is factorable. X minus 3 times x minus 1, and then don't forget to include the x minus 3 there from the 0, okay? The original 0 that they gave us. Let me draw a little arrow so you know where that part comes from, okay? So this comes from the factoring, and the other part comes from the 0 that they gave us. Okay, now, really, we should write this, since we have the exact same factors right here, we should write that as x minus 3 squared times x minus 1. That's how you would see it on an answer key. And here's an example of some multiplicity. Okay, 3, x minus 3 is 2 of our factors, so 3 is our root with multiplicity of 2. Okay. Now, number 19. That looks interesting, doesn't it? All right, turns out we can do synthetic division with square roots. It's not exactly pretty. It's not hard. You just have to be careful. Okay, so let's give it a shot. Okay, let's do synthetic division with 1 plus the square root of 41 on the shelf. So our coefficients, we've got 1, -8. You might want to space them out just a little bit more than usual because we're going to have to put a little bit more stuff in there. All right, let's see how this goes. So we bring down the 1. When we multiply 1 times 1 plus the square root of 41, well, that's 1 plus the square root of 41. And then when we add, all we can add here is the -8 and the 1. So -8 plus 1 is -7. And we've got to put the square root of 41 right there. Hang on. Let me think for a second. This isn't turning out. Oh, okay, we're good. Okay. All right, now we've got to multiply -7 plus the square root of 41 times 1 plus the square root of 41. We have to FOIL that. Okay, we've got to FOIL that. So -7 times +1 is -7. -7 times the square root of 41 is -7 square roots of 41. And then we've got 1 times the square root of 41. So we've got -7 of them plus 1. So we've got -6 square roots of 41. And then what happens when we multiply the square root of 41 and the square root of 41? It just gives us 41, okay? So I'm going to add -7 and 41. So -7 plus 41 is 34, right? So I'm just going to erase my -7 and put the 34 back there. Okay, keep going. All right, so -23 plus 34 is what, 11? And we've just got to keep that -6 square root of 41. We've got to FOIL again. So 11 times 1 is 11. I'm going to do the same thing I did before. I'm going to leave it there, and then I'm going to go back and erase it and change it. Okay? So 11 times 1 is 11. We've got 11 square roots of 41 and -6 square roots of 41. So we've got +5 square roots of 41. Now, check this out. I'm going to use my calculator here to show you what happens with multiplying the square root of 41 and -6 square roots of 41. Okay, what ends up happening is the square root of 41 times the square root of 41 is 41, but then we've got to multiply it by the -6 that was in front. So it's -246. But we got to combine it with that 11 that was in front. So we got -235 in front here. Now notice how that number got closer to that coefficient there. Okay, that's kind of supposed to happen. So now we've got -5 plus 5 square roots of 41. These numbers should stay fairly reasonable, small, I don't know what you want to call it. But the numbers you get right here, they should not be ginormous numbers. Okay? All right, almost there, -5 times 1 is -5. We've got -5 square roots of 41 and +5 square roots of 41. Praise the Lord, that square root of 41 finally went away. And then we've got 5 square roots of 41 times the square root of 41. So 5 times 41 is 205. And we had a -5 in front of that. So add the -5. That gives us 200, which is what's supposed to happen, right? We're supposed to end up with a remainder of 0. Okay, we're supposed to end up with a remainder of 0 here. Now, I don't know about you, but you're probably thinking, well, I've never seen a polynomial with square roots in the, as coefficients, okay? And you're right. Okay, but what's our property? If 1 plus the square root of 41 is one of our zeros, then what else is one of our zeros? 1 minus the square root of 41. So we're going to do synthetic division again, and guess what? They're going to go away. You know what? I was about to brag on y'all about not whining as much as last year's class did. You still haven't, okay? You still. I know this is not what y'all find fun, okay? I think this is fun. I'm not gonna lie. I think this is fun. But I'm a major nerd, so y'all know that, okay? I think it's fun to do problems that take some time, and then you got to do a lot of hard work, and then you get to the answer, okay? So instead of having to rewrite everything over, I'm just going to start another shelf, okay? All right, so bring down the 1. Okay, 1 minus, guess what? This one's not going to be as hard. Because 1 times 1 minus the square root of 41 is 1 minus the square root of 41. So we've got negative 6. Look at there. The square root of 41 went away. Because we've got plus the square root of 41 minus the square root of 41. So all we have is negative 6. If we add the numbers and add the square root. Okay, so then we multiply. Negative 6 times 1 is negative 6. Negative 6 times negative 6, or excuse me, negative 6 times negative square root of 41 is positive 6 square roots of 41. It cancels again, so 11 minus 6 is 5. 5 times 1 minus the square root of 41 is 5 minus 5 square roots of 41. Guess what? All that cancels. See, that one wasn't as bad. You just had to do the tough one once. So we started with x to the 4th. So our green line was x cubed. So that means now we're down to x squared. Can we factor that? I hope so. X minus 5 times x minus 1. Okay. Now, there is one more little piece of work that we got to do. Okay. We're not going to write x minus 1 minus the square root of 41 as our other zeros. So we do need to multiply this part out. So x minus 1 minus the square root of 41 times x minus 1 plus the square root of 41. We do need to multiply that out to make it look a little bit better to put this in factored form. Okay, so x squared minus x plus the square root of 41x minus x plus 1 minus the square root of 41 minus the square root of 41x plus the square root of 41 minus 41. So what cancels? Square root of 41, square root of 41x. So we've got x squared minus 2x. And 1 minus 41 is negative 40. Don't you feel accomplished?
No.
Oh.
I have more.
Okay, so here's the moral of the story. I know that I can FOIL things really, really well. I've been doing this for half my life. So you may need to, if you're doing a problem like this, you may need to go over to the side and say, okay, negative 7 plus the square root of 41 times 1 plus the square root of 41, put in parentheses, FOIL it out, do the intermediate steps. And that's fine, okay? Just have you a scrap sheet of paper. That's why I got the whiteboards, okay? Those are there for your use, for your disposal. To be able to get on my cotton green without doing stuff on the side, okay? I probably should have done it on the side so you can see. I'll do it on this one, okay? So similar thing with number 20, okay? Similar idea with number 20, except we've got an I instead of a square root. But guess what? Same kind of thing's going to happen, okay? Same kind of thing's going to happen here. So bear with me. Y'all are smart. You're here for a reason. Okay. But see, here's the thing. On the test, it's multiple choice. So you can just multiply it out. I think it's polynomials. Yeah. I mean that, the graphing stuff that we did, we graphed them, maximum, minimum, that sort of stuff. The factoring. Yeah, on polynomials. Like 20. Okay, so let's do this with the complex number. Okay, let's do this with the complex number. Okay, we're doing number 20. Yes, sir. Okay, bring down the 1. 1 times negative 2 plus 4i is negative 2 plus 4i. Add them together. Negative 4 plus 4i. Okay, you just add the real part together. Negative 2 and negative 2 is negative 4. 4i doesn't have anything to combine with. Now, I would really like for you to do this by hand, but don't forget, your calculator will multiply complex numbers for you. So really, on this one, now technically your calculator will multiply out the square roots too, but it doesn't give it back to you in nice square root form. But when it comes to complex numbers, it will give it to you in complex form. Okay, so negative 4 plus 4i times the negative 2 plus 4i on the shelf. The calculator tells me it's negative 8 minus 24i. So 4 plus negative 8 is negative 4. Guess what? You can even do that part of your calculator. Just add 4. And then multiply by negative 2 plus 4i. That comes next. 104 plus 32i. Now we did go over, foiling these. So you can do it by hand. But I'm just trying to make life a little bit easier on you. Okay, add the negative 88. Multiply by the number on the shelf. Negative 160. Oh, hello. That's what it's supposed to be. Because we get a remainder of 0. Okay? All right. So, same thing. We don't put i's in polynomials. But it's going to go away in the next step when we put the conjugate, negative 2 minus 4i, on the shelf. And guess what? This one's going to be a little bit nicer. We don't need the calculator because the i's are going to cancel if we do it right. No, positive 12. Thinking about too many things at one time. Negative 6 times negative 2 minus 4i is positive 12 plus 24i. The i's cancel. Negative 4 plus 12 is 8. 8 times negative 2 is negative 16. 8 times negative 4 is negative 32. That gives us 0. We started with x to the 4th. We did synthetic division once. That's x cubed. We did it again, so that's x squared. Can we factor this? I'm looking for somebody to say, yes, Ms. Redmond, we can factor that.
Yes, Ms. Redmond, we can factor that.
Thank you. X minus 4 times x minus 2. Okay? Now, again, we got to go over here to the side, and we got to make this complex thing look a little bit prettier. X plus 2 minus 4i. X plus 2 plus 4i. Multiply it out. X times x, x squared. X times 2, 2x. X times 4i, 4ix. Distribute the 2. Plus 2x plus 4 plus 8i. Distribute the negative 4i. Negative 4ix minus 8i. Let's see here. Negative 4 times positive 4 is negative 16. I times I is I squared, which is negative I, so that becomes positive 16. So 4ix cancels, the 8i cancels. So what are we left with? X squared plus 4x plus 4 plus 16, so plus 20. Okay, now the downside to this one, if we were trying to check it, the only thing that we could we can check it. You can plug the original Okay, into y1, you can plug the original or the factor form into y2. Okay, make sure that the y values match. What I was going to say is if you graph it, you're only going to see the zeros at positive 4 and positive 2. You're not going to see the other zeros because they're imaginary. Imaginary zeros don't cross the x-axis. Correct? Correct. Okay, so I want you to attempt numbers 34 through 40 even.